All right, recording. There's that. Let's get that going. I have that running. Okay. So let's go ahead and get started. If I can get my screen to turn on. There it goes. All right, guys. Where did my pointer stick go? Where's my pointy stick?
Is it really a pointy stick?
Oh, I got it. Wow. All right. So, guys, real quick review. Let's run through this. You ready? How many valence electrons does this have? Two. Here. 4. 1. 7. 8. All right. Charge.
Negative 1. Plus 2. 0. Plus 3.
All right. Good. You guys feel good about those?
Correct.
All right. So, you guys remember all of those, that helpful lie I told you about? Octet rule? Yeah. Totally. It's a true rule. You're going to use octet rule all the time. Okay? It's useful. But it's a useful lie. Okay? There's lots of times that we have useful lies, like telling a child about Santa Claus. Sorry if that's a surprise. What?
He's not real.
But
No.
Tooth Fairy.
When I found out Santa wasn't real, I just didn't tell my mom for a little bit because then I thought the presents would stop. I did the same thing.
All right. So
My parents
useful
still don't know
though,
that.
right? It kind of keeps. Honestly, I'm not a big fan of lying to my kids, but at the same time, I'm like, man, he gets nice around Thanksgiving. So it's a useful lie, right? Same thing. But the thing is, I want you guys to know the truth, even though it's going to be useful and you're going to be keeping everything wants 8 electrons. There's going to be, want you to know the truth about it. So today I'm going to be teaching you those complicated truths. That way you know them. All right? You guys remember how I said we're going to ignore all this? Well, guess what?
Now we're not ignoring it.
Not ignoring it. This? Nope. I know, right? So, this is going to be one of those interactive things where I'm going to be pointing, you guys call and response type stuff. So, no sleeping. All right. So, here's the thing. We talked about Bohr models, right? You guys are good with Bohr models? Can you guys draw these?
The lead one.
Lead one? Well, the lead one had an X through it. Hopefully you didn't do it because it had a big X through it.
You did it?
Let me see if I can find a good reaction. I had to Google how it was actually.
Oh, I know, right? There's a reason why there was an X there.
Yeah,
It only had an X on the board.
Yes. Yeah, you can do the rest of it, yeah.
Oh, I
But
didn't do the rest of it.
I still did.
just the Bohr model.
My brain saw the X and I was
All right.
like, no.
Okay, anyways, guys, bring it in. Bring it in. Bring it in. Thank you. So, Bohr model, you know that the first energy level has 2 electrons.
Correct.
The others have 8. Hold on now. So, but you can basically think like the first energy level is the first row of the periodic table, right? You have 2 there, okay? Why is it that this is kind of off on its own? This is kind of its own thing. This is kind of its own thing. This is kind of its own thing. The reason why is because electrons don't actually orbit around the nucleus like a planet, right? They don't do that. Well, it's there as a useful tool to let you realize this is an energy level. Okay? If I say that I'm at a really high energy level right now because I just had a bunch of coffee and I feel really good, I'm not actually elevated, right? My energy is elevated, right? So it's if you were to draw that, you would, here's an, like, normally I'm here, now I'm here. We gotta go from here to here. What it actually things look like are these things. Okay? There's a bunch of different shapes that these electron neighborhoods look like, okay? So, one of the simplest shapes is something called an s orbital. An s orbital, just a sphere, okay? So, you have a nucleus in the center, and then a sphere around it. That's the neighborhood that those electrons live in, okay? I'll go with that. Now, there's there's 2 electrons that can live in one orbital, one neighborhood. Okay? So this sphere shape around the nucleus can hold 2 electrons. Alright? So, there's that. There's also some other types of orbitals. That's the simplest one. You have p orbitals. P orbitals look like this. Like a little dumbbell, right? So instead of a sphere, there's a kind of an oblong sphere that goes this way, and an oblong sphere that goes the other way, okay? This is the shape of the neighborhood. So, how many electrons can fit into this orbital? 2, okay? All good? Now there are 3 different types of p orbitals. One that looks like this, going left and right. One that goes up, down. And one that goes forward and backward. Okay? We all good with that? So, how many electrons can fit in all of the p orbitals? So, there's 3 different kinds, and you can put 2 in each, so it's 6, right? So how many can fit in an S? S orbital, a sphere. 2. 1, 2. How many can fit in a P? All the P's put together? 6. 6. Whew. Now, if you keep moving on, you start getting into d orbitals. I'm not going to show you the shape of d orbitals. Let me blow this up a little bit. They look a little different. They're a little bit more complicated. Instead of 2 bulges, they have 4 bulges going in different directions. And in the middle, there's like a donut with a couple bulges. It's weird. You don't have to memorize these guys. What I do want you to know is, how many different types of d orbitals are there? 5. Okay? So how many electrons, so each one can fit 2, so how many electrons can fit in the d orbitals? 10. 10. All of these guys will end their electron, whenever you're putting electrons in, they'll stop, you'll run out of electrons and you'll be in the d orbital range. Okay? Keep going. F, these are even more weird. But how many are there?
12 or 6. Oh,
Seven. 7. So hang on, wait. You do 1, you put 3 down, right? So it's 1, add 1 to each side, you get 3. The next one, put 1 on each side, you get 5. Next one. So if I kept going, what do you think? How many do you think is going to be in the next? 9, right? So, exactly. So how many electrons are going to fit in these f orbitals down here? 14.
Oh, I saw 6.
I'm gonna just say, what do you think?
Probably 14.
14. Okay. So, on your periodic tables, go ahead and pull them out. You're going to be drawn on. I highly suggest it because what can you use on exams? These guys. This is what we call the S block. S block. Block. B-L-O-C-K. Block. So it's like a, So, we call it the S block because whenever you're putting electrons in, you're assigning electrons to different places. Where do you think you're going to end up? An S orbital, right? This is called the P block because you're going to end up in a P orbital. This is a D block. D as in dog. Because you're going to end up in a D orbital. This is the F block. Okay? So go ahead and you can start labeling those. If you have colored pencils are great. Yeah. P block. P as in Peter.
The one on your left, yeah.
S. Oh, these?
Yeah, which is at the bottom of the.
Yeah, that is going to be F. So I'm going to show you guys something. You guys, you ever wonder why I put string around and put it right here? Why is that?
Because it's supposed to be right there.
It's supposed to be right there. You want to know what the periodic table really should look like? There you go.
So what's visually appealing? That's long.
That's the periodic table the way it should be.
It's like they get
The problem is, will this fit in a textbook? It won't fit in a nice piece of paper. You have to make a scroll, and I don't want to be like a...
I can't even read it up there.
Exactly, right? It's hard. And most of the time, we don't deal with these things, right? These are things that you're not gonna mess with most of the time. So guess what? It kind of got shoved to the side to make things nice and pretty. So make sure that you at least remember that the F block does go right here. All right, we all good?
Yes.
Okay. So far, so good?
Yes.
Okay. So real quick, what's a sphere shape? S orbital. This dumbbell is a P. What are the different orientations?
Left, right.
Left, right, forward, backward,
Up and down.
up, down. Basically, like 3D,
Yes.
3 dimensions,
X, Y, and Z.
X, Y, Z, right? So, those 3 things. All right. We'll come back to this later. So, a little bit of terminology, okay? That way, we're not stepping on anyone's things. If I'm referring to the entire second energy level, everything in that energy level, I'm going to say the shell. Okay? So if I'm talking about everything in that second energy level, I'm going to say it's the second shell. And so in the second energy level, you're going to have an S and a P. Okay? But if you have P's, how many different P orbitals are there? 3. Okay? So, if I'm talking about a subshell, I'm talking about either S or all of the P's. Okay? If I'm talking about an orbital, I'm talking about a specific orbital. So, one of the P orbitals. Okay? So that's how I'm going to kind of divide those guys up.
For some shows, it's like the entire like P orbital.
All the P orbitals.
I guess within one orbital is just like one.
One orbital would be like just up, down. So if I said the P subshell, I'm talking about all of them. Up, down, left, right, forward, backward. Okay. And if I say the shell, I'm talking about everything in that second energy level. This S, the P, moving on. Okay? So the way this works is, if you have, in your first energy level, all that exists is an S orbital. Okay? In the second, you have S and P. In the third, you have S, P, and D. In the fourth, you have S, P, D, and F. Fifth, you have S, P, D, F, and then there's some other stuff that we're not going to get to. Okay? So you keep adding one more type of orbital every energy level. Okay? All good? Okay. Alright, so here's the truth of that useful lie. The number of electrons that can fit in each energy level is not 8. Because I told you before, right, that for the third energy level, or for let's go with this. That first energy level, I said, only has one type of orbital, which is a s orbital, sphere, right? One sphere, one s orbital. So how many electrons does it have? 2 electrons in it, right? So the second energy level, well, that still has another s orbital, but then it gets the new set, which are the p's. So how many p orbitals are there?
3.
There's 3 p orbitals. Each can have 2 electrons, so that's 6 more electrons. So 2 for this, and all the p's get 6, so that means it's 8. So far, so good. Okay. For 3, you have S, there's 2 of them. P's, there's 6 more. But then you get the D's as well. And remember, how many d orbitals were there? 5. Each of them has 2 electrons, so 10, 18 electrons. Okay? So for 4, same thing. S, P, D, 2, 6, 10. But then you throw in F, and that has 7 orbitals and 2 electrons, so it's 14. Add them up, 32. For F, you can keep going. F would get 50 electrons. If you wanted to, here's the formula for you math people out there. For whatever, if you wanted to know the 100th energy level, how many electrons would 100? There is none that have the 100 energy levels. This caps us out right around here, and that's only 7, right? But you can go through and figure out how many electrons would be in each of those energy levels by doing this. All right. So then why do we care about the octet rule? That's not fun. It's true. Everything does want 8 electrons in their highest energy level. Everything wants 8 electrons in the highest energy level. That part's true. But here's the reason why. Keep that in the back of your mind while I move on and talk about something else. Okay? Alright. So this thing. Geez, what crap is this thing? So this is called an off-vowel diagram. Off-vowel is some dude's name. A-U-F-B-A-U. Off-vowel. It's also just a fun word to say. This kind of goes through and it kind of shows the different orbitals based on their energy, right? So at the very bottom, the lowest energy, the first energy level, what orbital do you have? S. So we just have one S here, okay? So for that second energy level, we have an S, but then we also have some P's, 3 P orbitals, okay? So for the third energy level, you have S, and then you have P, and then you got 3 D. So the 3 here, whoop, don't worry about that. The 3 here means the third energy level, right? The D is what type of orbital it is. Okay? So 3s means it's third energy level, S orbital. 2p, second energy level, P's. Are we all good? good. Now, here's the thing. This is analogy time. Imagine this is a really weird apartment complex, okay? And this apartment complex does not have an elevator. If it does not have an elevator, what is instantly the most valuable room? Ground floor, right? Who wants to walk upstairs all day, every day? So, you want all the electrons, when you're giving electrons to an atom, right? You're kind of putting them in. They're going to go to that lowest energy level first. That's kind of what I was saying before, like everyone's that low energy level. They want to be chill. They don't want to be skydiving all day long. They want to sit on the couch and watch Netflix. So, we want to hang out here. Each of these orbitals, kind of think of it like an apartment. And each apartment has 2 beds. Okay? So, if I was going to go through and assign electrons to lithium, how many electrons do I need? How many electrons does lithium have? 3, right? So let's go through and assign them, okay? I'm going to put in 1 electron, 2 electrons. Oh, this room's full now. That 3rd electron has to take the next most valuable room, which is 2s. All right? All good so far? So I had to walk up some stairs, but it's not going to do anything else. I'm going to just walk up 1 flight of stairs. All right. We all good? All right. Let's do oxygen now. Oh, real quick. Let me get a. How many valence electrons does lithium have? 1. You can just see right here, right? Bam, 1. We know it. But look at this floor. How many electrons are in that top floor? 1. Same thing, right? This is the actual valence here. Okay? We all good? Okay. So let's continue on. Let's do oxygen, like I said. Shut up, you. Now, oxygen. How many electrons does oxygen have? 8. So oxygen is going to have 8 electrons. Same thing. Let's do it. 1, 2. This room's full. We move up to 2s. 3, 4. This room is full, so now we have to walk down the hallway a bit. This room is right next to the stairwell. That's down the hallway a bit. Okay? So now we have this suite of rooms, and there are 3 rooms here. How many people live with their brother and sister in their room? Anyone? Would you want to? God, no. Right? No one wants roommates. Do you think electrons want roommates? Heck no. So, we used up 4 electrons so far, right? Let's keep going on. I'm going to put in 1 electron in each room by themselves. Okay? But that's 1, 2, 3, 4, 5, 6, 7. We're not quite done yet. This next electron will be like, fine, I guess I'll have a roommate. Join in with one of them. Okay? We all good? Okay. So, how many valence electrons does oxygen have? 6. Hey, guess what's on the second floor? 1, 2, 3, 4, 5, 6 electrons, right? And if you guys remember the dot notation, 1, 2, 3, 4, 5, 6. How many single guys do we have? 2. Because they're singles in the orbital. Okay? You see why that works now? We all good with that? Cool. Okay. Now, let's do sodium. Okay? Sodium. How many electrons in sodium? 11, right? So, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ah, now this second floor is now completely full. We got to move up to the next floor. 11. All right? Now here's the thing, I'm a landlord. If I'm the landlord of this building, if no one's in a floor, do I have to power it? Do I have to heat it? Do I shut it down and save a whole heck of a lot of money? This floor now, I have to pay for this entire thing. For one resident, I may, no, I wouldn't charge them extra. What I would do is just kind of kick them out. And if sodium kicks out that electron, now it has 10 electrons, what's its charge?
1 plus.
See why it's 1 plus now? Now what about fluorine? How many does fluorine have? Fluorine, F. 9. Well, guess what? 1, 2, 3, 4, 5, 6, 7, 8, 9. Same idea here. I would love to maximize my profits as the landlord, right? If there's an empty bed, that's rent not getting paid to me, and I'm still doing it. So I'm going to want to fill that room as much as I can, right? So I'm going to try and shove an electron in there. And if fluorine does get another electron, what happens to its charge? -1, 1 minus. Okay. So do you kind of understand why they want to do that now? Yeah? They want to try and maximize that floor. All right. Whew. Let's talk. All right. Let's kind of put addresses to these guys now. Okay. Let's do an address. If I was to send a letter to these electrons, where would I write? Okay. So the way we write down the electron's address is pretty simple, right? You kind of see it right here already. It's 1s. So that 1 means it's which energy level? First energy level. S means it's the s orbitals, right? And then you're going to put how many electrons there are. Okay. So, for example, let's do lithium again. Okay. So, if I'm going to go through, I'm going to put 2 electrons there. So that means it's going to be 1s, 2 electrons. Right? And then I'm going to put another electron here because I need 3. So that's going to be 2s, 1. All good? Okay. So this is how you go through and write the address of the electrons. We call that the electron configuration.
So it's just whatever level it's at, and then however many.
Yep. How many electrons are currently in those rooms? Yep. So what about oxygen? What would oxygen be? Geez. Okay, hold on. That's going to be 1s2, 2s2, 2p. Oh, oxygen. What is that? Look at your cheat sheet. You ready for the best cheat sheet advice in the world for electron configurations? Just count it. Okay? So, if I'm wanting to do oxygen, I can just count it. First row, right? So that's 1. What block is this? S. There's 2 of them. 1s2. Here, this is second row, S block. There's 2 of them. So S, 2s2. Then move it over here. This is second row. What block is it? P. So 2p, 1, 2, 3, 4. So oxygen is going to be 2p4.
So
Are we?
just the 2p4 is not the rest of it?
No, all of it. Yeah. All of it. Because it has all those electrons. Yes?
So there's no like, so at the bottom there's no 1p or something on the second one, and stuff that would just go straight to 2p? Because like,
Yeah, there's no 1p.
Okay.
1p does not exist. 1d does not exist. 1f does not exist. every time you go up an energy level, you get a new type of orbital to play around with. So that's so 1 starts with just S, and then once you level up, to 2, now you get p orbitals to play around with. Once you get to 3, you get d orbitals to play around with. Okay. All right. We all good? All right, now let's go through and bring in those dreaded middle guys. Ugh. Let's do it. Let's do iron. Okay? How many electrons does iron have? 26. Okay? So hang on, let me write it down. Iron, 26 electrons. Same rules apply. These electrons are still lazy suckers, right? They don't want roommates, they're lazy suckers. Okay? Remember those 2 things. Now, so 1s, you get 2 in there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We keep going. 11, 12, 13, 14, 15, 16, 17, 18. Now we have a choice.
Okay.
Not even a choice, just an option. Now, this hallway is pretty long. It's like 500 yards. Would you rather walk up 1 more flight of stairs or walk 500 yards every day?
500 yards.
Really?
Yes.
Let's take a vote. How many people want to walk 500 yards down a hallway or go up 1 more flight of stairs?
Yards.
1 more flight of stairs.
How long
Thank you
is-
for saying what the obvious thing that I'm wanting
Wait,
you to
that's
say is.
how long is it?
500 yards is 1,500 feet, right?
Huh?
500 yards is
How long are the
1,500
stairs?
feet.
Yes!
Yeah, so stairs.
Yes, thank you! 1,500 feet is a huge amount!
It's obvious what he said.
500 yards is 5 football fields. So if you want to walk 5 football fields instead of walking 1 flight of stairs, whew!
Wait, is it what is stairs?
One flight of stairs is like walking up the stairs to go from the 2nd floor or the 1st floor to the 2nd
Is
floor.
that like a universal measurement? Or is it just
It's roughly 15 feet.
I didn't know if it was standards.
Depending on, I'm
Is there
sure
an
that.
SI unit for?
No. Good job. Okay. Enough of that. So you're going to go up the stairs, right? Which means you're going to go up to the next energy level. You're going to go to 4s before you go to 3d. Okay? So I hit, 18, 19, 20. Okay? Now you can go through and say, I don't want to walk up a flight of stairs and down the hallway. I'd rather walk to the D block. Okay? This is just how atoms work. Okay? I can show you why it is this way in a little bit, but just give me a
You
second.
have to write it like that too? Is that weird?
Yeah, you'll see. I'm gonna draw it out first, then I'm gonna write it out. Okay. So what? I got 18, 19, 20, 21, 22, 23, 24, 25, 26. Okay? All good? So now we can actually start writing this out. Okay? So if we're going to write it out, you can either go through, draw it out, and then write it, or use your cheat sheet and do it that way. So, for FE, we start at the top. What block is it? What row and block? 1s2 here. What is this? 2s2, 2p6. I'm waiting for everyone to say it, man.
Yes.
Okay, now we're here. Here's the thing. This is not 4th energy level, right? It's the 3rd energy level, But the reason why we shifted it down like this is because 4s gets filled first. Right? So if we're reading this like a book, left to right, we're reading it in the order the electrons go into things. So you just kind of have to remember. So get out your periodic table and kind of write a little note here, being like, this is 3D. Okay? 3D. The third energy level, D block. So D block starts with the third energy level, 3D. And so what would make this row below it? 4D. This one? 5D. This one? 6D. In fact, over here, this starts with 4. So this is 4F. And the next one down will be 5F. Okay? So, we keep going now. So this is 3D. 1, 2, 3, 4, 5, 6. 3D, 6. So this is the address of those electrons.
You said F is 4 and 5, right?
Yes. Do you see how this would be a lot easier to do than to do it that way? Use your periodic table. It's the best cheat sheet in the world. Okay, you ready for something real fun? You want to do Rutherfordium?
Yes.
Like named after the same Rutherford guy?
Yeah. 104. Oh boy! RF. RF 104. So, RF 104. Same idea though. So, hang on one second. Someone come up here and write for me. Because I'm going to come up here to the board. Right. Thank you. So, as we all say, and we all say it together, it's the best way to learn, guys. Just grab a marker and you're going to write on there. So just kind of write down, like, we say 1s2, you do 1s2. Okay? All right. So, you guys ready? Start at the beginning. Up here at the very top. 2p6. 3d. So yeah, this is 3. 3d. 10. Yeah. Now we keep going. We're back to the normal. So 4. 4p6. 5s2. 4d10.
5p6.
Yep. 6s2. And now we remember we gotta. So this is 4. 4. F. F14.
4.
Yep. 4F14. And now we're back over here. 5D10. 6. Okay. 7S2. Oh, did you do it? 5F14. Okay, now we're 6. 6D2.
Are we actually gonna have
Woo!
Good job.
Woo! Woo! Yeah. Yeah, I'll run you through like some practice problems. Alright, so guys, I'm gonna have you go through. I'm gonna give you guys some practice problems with these, but obviously this is super long, right? My God, is this super long? But what are the only electrons we care about? Valence, the outer shells, right? Most of those we don't care about. So, there is a shortcut version of this. Okay? So, what you do, did I tell you that what these guys are called? So, yeah, these guys are called the noble gases. Hey, see that storage? Yeah. Okay. So, those are the noble gases, right? So this is called noble gas notation. So, here's the thing. Noble gases, remember we said that these guys didn't do anything. They don't really react with anything. They got that perfect 8, so on and so forth, right? Perfect 8. So what we do is, instead of writing out everything, we find the thing we want, Rutherfordium, and then we go up to the nearest noble gas. Radon, Ra. So, we write down in square brackets the symbol, okay? And this basically says, hey, you know all the orbitals and everything up to here? They're all full. They're all done. Don't worry about them. We've taken account of them. And then you keep going. So from here you go here. And what's this? 7s2. And then keep going.
Thanks, sir.
Yep. And where are these? Oh, yeah, these.
5 14. And then 2D.
Nope.
Oh, wait, no, 7D.
3, 4, 5.
62.
62. Is that a lot easier to write? Yes, very much so. I would imagine. Connor knows. So all of you, I'm going to give you a homework, and I'm going to make you do it the long way, make you do it the short way, make you do it all the ways in between. Okay?
So,
Yeah.
the one you said, so you start at that row,
So,
whatever
yeah.
row it's on, you start at the end of it and then goes there?
Yeah, you kind of be like, okay, if I'm doing hafnium here,
You start at
I would start with xenon.
So the one above it?
Yeah,
Okay.
yeah. 'Cause you can't go backwards, right?
Yeah.
So, go here, and then it would be xenon 6s.
It's the same thing, you just start.
It's a different starting point, yeah. Yeah. All good? Okay.
I say that now.
Well, hey, don't worry. I'm gonna give you guys some practice tomorrow. Okay? No, I'm gonna have you do some tomorrow. I may put it online tonight, but we'll have time tomorrow to work on it. Okay. This is definitely one where, like, it takes a bit of practice, but the process is not super hard. Okay. Are we all good? Here's the thing, guys. You guys saw this whole thing, right? 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s. It kind of jumps around, right? Okay. The reason why it is this way, if you look at this, this is energy, right? How much energy does it take to get from ground floor to that apartment complex, right? Or that apartment suite? So, like 3D, it takes longer and more energy to get to than 4S. We kind of talked about that. Walking down a long hallway as opposed to going up a flight of stairs. So, but because of that, the energy it takes to get to different places gets shifted around. Yeah? The periodic table is set up this way so you can just read it left to right and get it. So, good on the periodic table. Okay. Here's the thing though. What's the definition of a valence electron? Outer shell. Outer shell. Right? So, that means how many electrons did were in 3 when we started adding 4? There was 8, right? 8 total in 3, and then we jump back to 1, right? Let's keep going with this idea. What about 4? 4 we'll get 1, 2, and then you put in a bunch for 3. 1, 2, 3, 4, 5. So now we have 8 again in 4, and then it goes from 4 to 5s. Oh, that 8 is 8 there. See what I mean? No? Kinda, sorta? So, I'm gonna write this down. So I'm gonna say, write down, highest energy level, okay? And then I'm gonna say valence electrons, okay? So as we go, we're gonna talk about what's there. Okay, so let's talk here. So chlorine, what's the highest energy level for chlorine? 3. How many valence does it have? 7, right? So that's basically saying we're going up to here, right? This is full, 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 and we're here, right? And let's keep going to neon. Now we have still 3 energy levels. We have 8 valence. This is now completely full, right? What happens if I add 1 more? Do I add into 3D? No, I add to 4s. So when that happens, now what's the highest energy level? 4. How many valence do we have? 1, right? And so let's keep going. Okay, we keep going. 2, 3, 4, 5, 6, 7, 8. Now we have 8 valence electrons in the 4th energy level. And let's say I add 1 more. Where does it get added? 5s. Okay, now what's the highest energy level? 5. So how many valence do we have now? 1. The valence electrons won't ever get past 8, is what I'm trying to say. As soon as you get 8 and you add 1 more, a new higher energy level pops up, which means it's now back to 1 valence electron. So that's why the octet rule still applies. Okay? You'll always still want to have 8 in your highest energy level. Okay. Okay. Questions, comments, concerns? Yeah.
Whenever you get to whichever one the highest would be the 4th energy level, where it has all of them, all of the orbitals, then does it past that is 4, 5, 6, is that all going to be the max the same, or is it keep going up?
I'm not quite for sure what you're talking about.
Look, so on the board it doesn't go, once you hit purple it doesn't go any further than that. Could you still add more?
Yeah, so there are H orbitals, G orbitals, and things like that.
Yeah.
The thing is, they're going to be, like if I kept going here, the next orbital thing is going to be way up here. I mean, do blue so you can see it up here. So it's going to be way up here, right? And here, it's going to be way up here, yeah? So, sure, they're there, but we're going to have to make more elements in order to see those in chemistry class. So yeah, they do exist, they're there, but they just stay empty because, yeah.
Like, whenever you're setting up the levels and stuff, like you start at X, I would say like you have, like, so you fill up S and D first to get 8, then you go up, fill up the next S, then you go back down, fill up D.
No, okay, so remember that this is just kind of like an abstraction. This is just kind of an example or a diagram, right? So if you want to know kind of what's really happening, I'll draw this on the board so people video can see it. Okay, so imagine you have the nucleus, and you have a whole bunch of orbitals, blah, 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 and you finally get to 4s, right? 4s, it's a sphere, right? So there's my two-dimensional sphere. You're wondering, why doesn't 3D get filled? So, remember 3D was those weird shapes, right? This is why. And then there's like one that goes up, there's a donut, there's one that goes over here. If you do, this is kind of more up here. So these orbitals, because they're all overlapping each other, if you just take like the average volume of the sphere and the average volume of all the d orbitals, the fourth s is going to be closer to the nucleus than the d's. Does that make sense?
Yeah.
So because of that, it's easier to fill the 4s. It's at a lower energy level.
Okay. Like, it's just...
It's a little weird. This is literally your first step into quantum physics.
Yeah, like, I don't know if it would be easier if I was trying to, like, move from the table, but from the board, like, the thing you have on the front board, it's just going back down. Like, whenever it would jump from, like, whenever you said it was, like, jumping around on the stuff I wrote down on the board, like, whenever it goes back down, it's just easier to see from the table than...
Oh yeah, because you can see like 3D is obviously higher than 4s, right? Yeah. The problem is that you won't always have this. The periodic table you'll always have. So that's one reason why the periodic table is nice. The other thing you can do, is this thing. This is something that a lot of people like hand out. This is kind of the cheap version of it. It's a little thing you do. So what you can do is, like, if you're sitting down at the test and you forget, geez, is it 3D before 4s? No, 4s before 3, I don't know. This is one way that you can do it. You can do, just write down 1s, and then underneath it, right underneath it, 2s, space over, 2p, because now we're adding in some p's. Keep going. 3s, 3p, 3d, 4s, 4p, 4d, 4f, and then 5s, blah, 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 blah. And then the way you fill is just diagonals. Start here, 1s. Next, 2s. 2p, 3s. 3p, 4s. 3d, 4p, 5s. 4d, and so on and so forth. Okay? So that may help you just as another way of doing it. The problem is, again, this won't be on a test. This is something that you'll have to sit down on the test and then quickly write down. You know what I mean?
Yeah.
But this is another method to remember that order. I've always just used the periodic table because it's literally just count left to right. Okay, as long as you remember S block, P block, D block, F block, you just count left to right. Okay. All right. We got a little bit of time left. Let me talk about these rules. Okay. These are just terms. You just have to remember, like, what rule is this? Oh, it's off-bow rule. Ugh. Okay. So, off-bow rule is that electrons fill their lowest energy level. Another word for that, or another term for that is the lazy tenant rule, because they're lazy tenants in the apartment complex. Okay? But off-vowel rule. Okay? I didn't talk about this yet. I'll talk about it in a second. Let's go to Hund's rule. Hund's rule is each electron must fill empty orbitals before sharing. Essentially, they don't want roommates. Okay? And the last thing is electrons can't have the same spin. Now, I'm not going to get into what is spin. I mean, I know there's freaking physics grad students that still ask, what is spin? It's hard. Essentially, have you guys ever seen, like, if you have a charge, if you spin a magnet, what happens? You might know. Have you taken physics? If you spin a magnet, what happens? How does an alternator work in your car? Does anyone know? So, basically, an alternator has a bunch of magnets, and they all spin. It generates electricity. But then again, you can also do it the opposite way, where if you spin a charged thing, it makes a magnet. Okay? So, if you have an electron, and it's spinning, what happens? It makes a magnetic pole. Okay? So, basically, here's the thing. If one electron is going up, spinning upwards, the other is spinning down. That's all it's saying. They don't spin the same way. When you're drawing these guys, I drew dots. The appropriate way to do it is to draw arrows going up and then arrows going down. That's the appropriate way to do it. So, there's that. All right, there's that. I'll have an assignment tomorrow going through those electron configurations. How do you guys feel?